Alright, so the first time I recorded this video, I didn't have sound. I don't know. Microphone didn't work, I guess. So, I'm going to re-record this on this snowy Thursday morning. So, here we go. I'll just watch and see what I did and talk you through it. So, this particular function is an exponential function. It looks like it's exponential growth, but in reality, because of that negative exponent, we're going to find out here that, look how I'm rewriting it as 3 to the negative first. Remember, the negative first exponent causes the base to flip over. That becomes 1/3, right? So now we know it's actually exponential decay. But you and I both knew it was exponential decay because when you look at the picture, it looks like it's going down as you go farther to the right. All right? Now, then they have this +2 thing on the outside. We know that when the shift is on the outside, that means it's either up or down, and it goes with your common sense going up. All right, well, guess what? That fits the picture. So the picture shows an exponential decay function that's been shifted up. They're asking me about domain. Remember domain? That first question about domain is where we are. I told you to kind of push all of the values onto the x-axis and tell me how much of the x-axis gets covered. Well, now hopefully I'll draw it here in a second. Yep, so I'm pushing all the x values down, and folks, it goes on forever to the right and forever to the left, because it'll just keep getting higher and higher, so you'll be able to put more values on the left too. So I'm hoping that you're going to say to me, oh, Mr. Staley, that's all reals. Yep. That's what it is. It's all reals. And you can write the phrase all reals. Or if you really would like, you can use the cool capital R with a double bar. Or if you like interval notation, you can put negative infinity to infinity. Some of you like the interval notation, but you don't need to do that. You can just write all reals. There's the R with the double bar, which is what they flash in the sign, the sign they flash in the sky when they need me to use my superpowers of mathematics to help people. And, which is typically a daily thing, It's kind of hard to see in a cloud cover, so they have to shine it up on a building. But the other one is the one I just drew up there is the natural numbers. That's the N with the double bar. I probably drew that one so that you could see. Hold on a second. Let me see if that's the 1, 2, 3, 4, 5. But maybe I showed that so that I could tell you about the shirt that I made with that design. Here, I'll find it. So yes, from my Teespring website, tattoos I'm too scared to get. As you can see, I would use the all-natural, the natural number symbol and the real number symbol, and I would tattoo them on the inside of my biceps. All natural, all real. And you can get that in a variety of, you can get that in a sweatshirt, or you could get it in a coffee mug. I need to add some things to it, like, a tumbler, or there's a long sleeve shirt. And then, of course, a tank top. I got one student at Homestead that has this tank top. And then it's Scavo. If you want to see it, you can ask him about it. But we should make some socks out of that. Remember, all proceeds go to a charitable foundation, not me. Okay, I don't keep any of that money. Anyway, that's maybe why I showed you the all-natural symbol, because it really doesn't apply to this situation. Okay, back to the math. All right, we're back. Let's see if we can figure out. Oh, we're going to the next question. All right, so this, what are we going back for? I don't know. I'm confused. Why is Mr. Staley going back to the old problem? Oh, we forgot the range. Duh. That's my bad. Somebody probably yelled at me. But Mr. Staley, we forgot the range. All right, so now, because this is kind of the important part, remember how we said that the vertical shifts were the only ones that would change the range? If you push the whole graph up, then instead of being y is greater than 0, it would say y is greater than 2. And if that doesn't make sense, maybe we'll show a better picture on a different question here. Okay. Set up a table of coordinates for the following function. Integers -2 to 2, inclusive for x. Then use the table. Okay, so they want me to make a table of numbers. All right. Maybe we'll make a table of numbers, although there's only 2 graphs that look like exponential growth. And this is 2 to the x, so it is clearly exponential growth. So, and D and A are bad fake answers. They actually have a negative A value, and I'm not going to really get into negative A values. So I think we can get rid of A and D pretty quickly. Come on, what's Mr. Staley writing? Growth. Okay, wow, it took him a while to write that down. Whoa. And then there's a -2, which shifts it down, right? When it's on the outside, it goes with your common sense. And it's either up or down. In this case, being negative, it is down. So the only graph that is exponential growth that's been shifted down would have to be letter B. We'll just see how long it takes Mr. Staley to circle letter B. Come on, Mr. Staley, you can do it. What is he waiting for? I mean, letter C would be an exponential growth function, but it's been shifted up 2 units, not down. I wonder what he is waiting on. Oh, there he goes. There he goes. Whew, man, took him a while. Okay. I knew he was going to get around to it eventually. Come on, next question. All right. Okay, now this one, the change is happening with the x. And remember, every time we said the change happens with the x, it would be backwards of your common sense. All right. Now, yeah, B and C are bad choices. I'm not going to be flipping these things upside down on you. So we're not worried about those. We do have an exponential growth function. Well, that right there answers the question, because only one of them is exponential growth, and that's letter D. You didn't even have to worry about the whole left 2 thing going on that they have. And that is left 2. It goes against your common sense when it's with the x. It goes with your common sense when it's the y. This is exactly the same way it was for parabolas, or square root functions, or cube root functions. It's all the same. It's just, so this one is exponential growth, because +4 is bigger than 1. And it's moving 4 units to the right. So exponential growth that's being moved 4 units to the right. Once again, we have some really bad fake choices in B and C. You can get rid of those. We don't need to look at those. Hopefully Mr. Staley will cross those out sometime soon. What is he waiting on? Let's see if I can figure this out. Come on, Mr. Staley. Cross something off here. It seems like it's going slower than I want it to go. I wonder if we could speed it up. Ooh, I bet I could. I bet I could. Yep, there's A. Okay, I'm going to go over here to the playback speed and go 1.25. Then your notes can be done faster. Because who knows what Mr. Staley's talking about right now. He could be telling a joke. I'm not sure. Let's see. Does he go on soon? Okay. Maybe he's now answering the question. Oh, yeah. Okay. I think that's good enough. Yep, go on to the next one. All right. So we got exponential growth, right? Because you got that 2 to the x. That's growing. So it can't be A or B because those are upside down. So you can get rid of A and B. Those are bad choices. Then it is being shifted down 5. So find an exponential growth function that's shifted down 5. And that would have to be the one and only letter D. I'm not sure when Mr. Staley's going to get around to circling that one. But it is going down 5. Come on, Mr. Staley. Yep, there we go. Growth. I'm writing a little faster. That's, kind of cool. And is he going to write down 5? I don't know if he's going to write down 5, but he did circle the right answer. Yay, Mr. Staley. It's kind of weird when I'm watching myself write stuff down, but I'm not actually writing it at the moment. Come on, is he going to write the word down? Or is he just going to talk about it? Okay. Yes. I wonder if we talk about domain and range on this question, just for kicks and giggles. Oh, yeah. Let's talk domain and range. I'm hoping he is. Yeah, domain and range. Awesome. Okay. So remember, domain means push all the values onto the x-axis. Well, if you do that, this thing, guess what? Every single time you come to one of these questions, it's all reals. That's not the tricky part. The tricky part's the range. So hopefully he's going to write down all reals. Why is he taking forever? Come on. What you got going on here? Are the kids thinking about it? Maybe I'm letting the kids think about it. It's time to speed up, Mr. Staley. There we go. All reals. Okay, now it's the range we have to worry about. Range is the issue, right? This is the one where you push all the values onto the y-axis. Remember, this thing has been moved down 5. So that's got to be everything greater than -5. -5 is that asymptote on the graph that I've talked so much about. So you can push all the values onto the y-axis, but you'll never go below -5, right? Because that's the asymptote of the graph. And we don't touch the asymptote. Never. Okay. What's he rambling on about now? Oh, maybe going to the next one? Maybe. Yep, going to the next one. Okay. Question 12. Ooh, now we're into an exponential decay function. Okay, because 1/3 is smaller than 1. And it's been moved up 2. So I got to find an exponential decay. And of course, A and D are your fake answers because they've got the negative multiplier or negative A value. And I'm not doing that to you. So exponential decay been shifted up 2. There's only one, and that is letter choice B. And I'm not sure why I circled B, and now I'm going to tell you it's decay and up 2. Seems backwards. Seems like I should have discussed that with you before making the final choice. Maybe it's just because people in class already knew the answer and chose it. Come on, write down decay. Thank you. And then circle the +2 and tell them it's up. Come on, faster, Mr. Staley. Faster. What's he waiting for? Okay, let's talk domain and range. Domain, well, that's the easy, the all reals. Range, y greater than 2. That's right, that makes sense because it's been shifted up 2 units. So all the y values have to be bigger than that number because y equals 2 is the new asymptote. Hold on a second. All right, I'm back. Sorry, brief interruption. What is Mr. Staley waiting on? Sorry, I'm going to advance to the next slide. There we go. All right, question 13. Exponential growth, because 5 is larger than 1, and it's been shifted to the right 1 unit. Remember, it's opposite of your common sense for the x, but it's exactly what you think for the y. Now, this thing has not gone up and down at all, but it has been moved to the right 1 unit. Now, there's only, okay, I'm not doing any upside down ones, so A and C are definitely out. Let's see if we can fast forward. Cross that one off. And come on, cross off that one. Yep. So now we're looking for exponential growth. It's been moved to the right 1 unit. Okay. Well, it definitely can't be D because D is down 1 unit. So it has to be choice B. It has to be choice B. And circle B. There we go. Are we talking domain range? Or are we going to go on to the next question? What are we doing? I think we're going to go to the next question. We are. All right. The graph of an exponential function is given. Match the graph to one of the following functions. Okay, it's got to be exponential growth. But that doesn't help me because all of them are, an exponential growth function because they all have 3 to the x. This one has not been moved up or down, so get rid of B and D. Those are bad choices. It's either been moved left or right or not at all. And A tells me it's been moved to the left. C tells me it has not been moved at all. So I'm actually going to have to look at some points here to see what's going on here. So I'll have to plug in, say, a 0. I see on the graph there you got a 0.13. So if I plug in a 1, I get 3. So between A and C, I have to plug in a 1 and see which one gives me 3. And I think if you plug it into letter A, you would get 3 to the 1 plus 2 power. That'd be 3 to the third, which is 27. Right there, that gets rid of choice A. But choice C, which is 3 to the first power, that's a good answer. So letter C is the winner out of this. Let's see what I'm actually going to write down. Come on, what am I going to write down? 1, 3. Come on, let's fast forward a little bit. What's going on here? Nope, yeah, so we got rid of those because those are up and down shifts. And am I going to do any algebra here like I've been talking about? There we go. We plugged in 1 into the C function and it gave us 3, so that's the winner. If you plug it into the A function, you get 3 to the third, which is 27, which is not true. All right, time to move on. Question 15. Okay, so what is going on here? Oh, I think sometimes it draws in an extra part to the graph on Math Excel. I don't know why I was demonstrating that, which is not actually on the graph. Okay, so exponential growth. It's been moved up 4. Domain, remember you push them all onto the x-axis, but remember they're all reals for these for domain. Range. Okay, range is when you push them all onto the y-axis forever and ever. But as you can see, nothing's ever going to go below 4. The whole graph got pushed up 4 units. So all the y values are bigger than 4. How long will it take me to write that down? Hey, there it is. Y is greater than 4. It's never equal to that number because of the asymptote situation. Never. It's always greater than. Since we're not flipping these things upside down, we're never going to have a less than either. Graph the exponential function. Okay, it's growth, and it's being shifted up 1 unit. So I need exponential growth. A and D are obviously wrong answers because we're not doing the negative A value. So the only one that's growth and been moved up 1 unit is letter B. We're getting these notes done. Growth, and it's been moved left, right? Left. Don't say left, right. That's confusing. Left 1 unit. It's always backwards of your common sense with the X. Can't be A and B. Yeah, those are ridiculous upside down choices. So we're looking for something left. And it has not been moved up at all because there's no +1 on the outside of the function. So it's not D. It must be choice C, the winner. All right. 18 here. So we've been given a function and told to translate the function left 9 and down 5. Okay, so we have to decide what the parent function is, And it's pretty easy. If I zoom in enough, you can see on the graph. Will I zoom in on the graph? When am I going to zoom in on the graph? Am I continuing to ramble on? Okay, right about in here. So something to the x. Oh, I know what I was saying. That the a value has to be a 1 because it is the y-intercept. Remember how I talked about the a value being the y-intercept? Well, in this case, it crosses right there at 1. Therefore, we know the a value is 1. Now I'm going to use this coordinate 1, 2, right? 1, 2. And we have to basically plug it in to the function. Well, it should help us figure out what the b value is. If you have an x value of 1 and a y value of 2, it helps you find out what b is. Come on, is he going to write down the y value of 2? Okay, good. And the b value. Well, it's not really hard to solve that because it already is solved. B has to be 2. So now we know the original function. And yes, you're right, folks. You don't have to write the 1. You could just write, that's your original function. You could just write y equals 2 to the x if you wanted to. Now we're going to get to the changing the function so that it goes left 9 and down 5. So just think about that. How do I change the x, and what do I put on the outside of the function to make it go down? So, is it going to be x minus 9? Or is it going to be x plus 9? Is there going to be a minus 5 on the outside or a plus 5 on the outside? Remember how I talked about it goes against common sense for the x, but it's exactly like the common sense for the y? Okay. When am I going to get around to it? Come on. Maybe I'm letting the kids work on it on their own. Oh, we're getting close, I think. Something going to appear? 2, right? That's the growth factor. If we want to go left 9, that would be x plus 9 in the exponent. Come on, one of these days. There we go, x plus 9 in the exponent. But then because we want to go down 5, we put a minus 5 on the outside, like that. So that right there is the function that says exponential growth with a growth factor of 2, the a value is 1, and we're going left 9 and down 5. Left 9 and down 5. And I think that's the end of these notes. And looky there, I turned a 33-minute video into a 23-minute video. You can thank me later.